So, Math 20-1, quadratic equations and functions. We're looking at lesson 1, which is factoring. So, just so you know, I'm Finley, and these are my notes. All right. So, before we do quadratics, we really need to review factoring because we use that a lot. So, let's look. This should be a bit of a review, some of it from Math 10C, and we'll do some extra practice. So, first one, just dealing with the basic trinomial. So where a is equal to 1 in our AX AX is equal to 1, right? So there is no coefficient other than a 1 in front of the x squared. So we want to ask some questions. We want to look at the last term and the middle term. This is by inspection. So we want two numbers that multiply to give you minus 21 and add to give minus 4. So I've inspected the terms of the equation and I want to look for those connections. Thinking about the opposite of FOIL because those are going to be the terms in the last position of the binomials. Okay, so two numbers that multiply to give you minus 21 and add to give minus 4. That's going to be minus 7 times plus 3, right? So I just basically take, it's going to be x minus 7, x plus 3. Okay, so that's inspection. Now, also we want to think about greatest common factor. If I have a trinomial that is not just a basic trinomial, there is a factor in front of the first term. First thing I want to do is I want to look and see, can I factor out a greatest common factor? And in this case, yes, I can. So 2a squared minus a minus 12. And then I'm looking for two numbers that multiply to give me minus 24 and add up to went back to the original equation. They multiply to give me minus 12 and add up to minus 1. And the two numbers are going to be minus 4 and positive 3. Minus 4 times positive 3 gives me minus 12. Minus 4 plus positive 3 gives me minus 1. So do not lose your coefficient. It's still there. It'll be a minus 4, a plus 3. And if you're wondering, how do I know if these are correct? You can always FOIL and distribute to see if you get back to your original equation, and you will. Okay? So that was greatest common factor. And I'm a big fan of saying common factor first. That is a slogan. Now, my favorite factoring is the difference of squares. So that follows the pattern a squared minus b squared is equal to a minus b times a plus b. Okay, so if you have two terms, both of which are a perfect square, this is going to fall, and they're separated by a minus sign. This will follow the pattern for difference of squares. So here we'll get m minus 4n. That's the square root of each of those terms, and then m plus 4n. Okay, so basically all I did for this is I took the square root of m squared, which is m, and the square root of 16n squared, which is 4n. And those become my two terms. Okay, you don't have to write that workout. You probably can do that in your head. Product, sum, decomposition. So decomposition, here we don't have our simple trinomials, it's complex. So what we do is we multiply the first and last terms. So we go 9 times 4, which is 36. So I want two numbers that multiply to give me 36 and add up to the middle term, 12. And what I'm going to do is I'm going to use these to decompose the middle term. And decompose means break apart, okay? So I'm going to break up the 2b, or the 12b, into my terms. So my two numbers are going to be 6 and 6. So I'm going to break 12b into 6b plus 6b, okay? So I write that out, 9b squared plus 6b plus 6b plus 4. I haven't changed anything. All I've done is broken that 12b into two different terms. Okay, they're still there. Then I group and I factor. So when I factor, I look at each of the two brackets that I've now made, and I'm going to factor out a common factor. So from each of these, I can take out a 3b, and I get 3b plus 2. And for the second term, I can take out a 2, and I get 3b plus 2. Now, this one is actually a nice special one. So I factor out my 3b plus 2, and I get 3b plus 2. So that one, this will make up the other bracket. This is actually a perfect square. And sometimes that happens. Sometimes you can recognize them. So you can also write it as such. Okay. Okay, moving on to the next page. Hopefully this is review for all of these. Perfect square trinomial, which we actually kind of just did one by accident. So in a perfect square trinomial, for example, x squared plus 10x plus 25, the first and last terms must be perfect squares, and the middle term must be twice the product of the square roots of the first and last terms. So x squared is a perfect square, and 25 is a perfect square. And if we look at the perfect square, if we took these, the 5 and the x, and we times them by 2, we would get our middle term, and yes, we do. Okay, so basically we multiply the square roots of the first and last term by 2, and if they give us that middle term, then we have a perfect square. So factoring this, it's going to be x plus 5 times x plus 5, or x plus 5 squared. Now some of that is recognition. If you still did using inspection, two numbers that multiply to give me 25 and add up by 10, you would still get the same answers because it would be 5 and 5. And a lot of times too, like the last one we did on the previous page, if you do simple decomposition, you still get your correct answer. So there's a lot of ways to get there. This is just a recognition of a pattern. Okay, so we can see that pattern. So determining if a binomial is a factor. So the only way you can really do this is by factoring. So take a look at your question and you want to factor. Now, I like to say common factor first. So looking at this one here, I have 4x squared plus 10x minus 6. They're all divisible by 2. If I factor out that 2, it's going to make my work easier. Now, I still have a factor in front of the x squared. I can tell it's not a perfect square, so I'm going to have to use decomposition. Okay? So I multiply my first and last terms, and I get -6. So I want two numbers that multiply to give me -6, and they have to add up to that middle term because that's the one I'm going to break apart. So they have to add up to +5. So the two numbers are +6 and -1. Those will add up to +5 and multiply to give me -6. So here I'm going to break that apart. So it'll be plus 6x plus negative 1x minus 3. Now I'm going to group and I'm going to factor. Be careful with your brackets because I've got that common factor there. So here I can factor out a 2x and I'll get 1 plus 3. And here I can factor out a negative 1 and I'll get, oh sorry, this is x plus 3. And a big tip with decomposition, if you get the same terms there, I've factored out that common factor, then you know you're on your right track. The other values make up your other bracket. So one bracket is my x plus 3, and the other bracket is my 2x minus 1. So going back to the original question, is x plus 3 a factor? It sure is, because there it is. So yes, x plus 3 is a factor. Okay? And it doesn't matter what order it's in, they all work. Okay? So, next one. We want to know, is x plus 3 a factor? So we need to factor it. Now again, this is one we're going to have to use decomposition. I can't common factor anything out. So it'll be, for multiplying, it is 2 times negative 15, which is negative 30. And it needs to add up to 1. So my two numbers are negative 5 and 6. Negative 5 times 6 is negative 30, and negative 5 plus 6 is 1. So 2x squared, negative 5x, plus 1x, minus 15. So do my grouping. Hopefully you can see that. First one, all I can take out is an x. So I'll get 2x minus 5. I did something wrong here. This should be a 6, right? My mistake. It's negative 5 and a negative 6. It's okay. Whew. I was like, that doesn't work. And then I'm going to take out a 3. And I get 2x minus 5. Big tip off, we're on the right track because I can factor out that common factor. And then I get x plus 3, so whatever's remaining, times 2x minus 5. Where did I get that x plus 3? From here and from there. That makes up my first bracket. So that's the question. Is x plus 3 a factor? Yes, x plus 3 is a factor. Very different trinomials, but x plus 3 is a factor of both of them. Okay, your turn. So this is the point where you kind of test your own thing. So pause the video, try them, and then come back and see if you get the correct answer. So this one is asking, is d minus 4, I'm assuming you're back from trying them on your own, a factor of each trinomial, and you have to justify the answer. So you justify by factoring and seeing if it's one of the factors. So first one, I'm going to common factor first. So 2 times d squared plus 3d minus 28. So I need two numbers that multiply to give me minus 28 and add up to plus 3. So I'm looking at these terms. I'm using inspection to solve this one. So two numbers that multiply to give me minus 28 and add up to plus 3 are plus 7 and minus 4. So d plus 7, d minus 4. So is d minus 4 a factor? Yes. Okay. D minus 4 is a factor. Okay. Next one, I have 3d squared plus 13d plus 4. It's not a simple trinomial. I can't common factor, so I've got to use decomposition. All right. So 3 times 4 This is for my multiplication number, gives me 12, and they need to add up to 13, so it's going to be 12 and 1. Okay, so 3d squared plus 12d plus 1d plus 4, and then I group and I factor. So when I do that, here I can take out a 3d, and I get d plus 4. And here I can't take anything out. So the rule is if you can't take anything out, take out a 1. So I'm going to factor out a 1 from both of these and get d plus 4. So I'll get 3d plus 1 times d plus 4. So here, no, d minus 4 is not a factor. Okay. Alrighty. So remember, this and this is where you get this from. I just take what's left over. Basically, what I'm doing is dividing d plus 4 out as a common factor. Okay. Factoring with fractions or decimal coefficients. So we'll take a look at that. So if you want to factor out you want to get rid of these decimal coefficients, we're going to factor out the 0.1, which is like multiplying by 10. So let's do that. So we factor out 0.1 from this, 0.1. So what will happen then is I'll get a 10x squared plus 14x minus 12. So try that. If you take 1 divided by 0.1, you'll get 10. If you take a 1.4 divided by 0.1, you get 14. And a 1.2 divided by 0.1 will give you 12. Now, looking at that, I still have a common factor. I can divide out a 2 from all of these. So if I divide that 2 out, this actually becomes 1.1 times 2. So this will become 0.2, and I'll get 5x squared plus 7x minus 6. And I did that to make it simpler. Now we still have to do decomposition, right? So I need two numbers that multiply to give me negative 30 and add up to 7. So the two numbers are going to be 10 and negative 3. Okay? So I'm going to decompose that middle term, 7x, into 10x plus negative 3x. So 0.2, 5x squared plus 10x plus minus 3x minus 6. And then I'm going to group. And you'll notice I put a plus minus 3x. That's just so I don't lose that negative sign. So here I can take out a 5x, and I'll get x plus 2. And here I can take out a negative 3, and I'll get x plus 2. So my final answer will give me 5x minus 3 times x plus 2. Okay, so by what you say, okay, but you know, why did you factor out the decimal? Well, it's really hard for us to think in our brains about factors of decimal numbers. Same things with fractions. So why not just eliminate them so that you can do that factoring? We still have it hanging around. It's still part of the expression, so that it's still there, but we've just simplified it. So on this next one, it's a fraction. We're going to factor out the 1/2, which is like multiplying by 2, and then factor the trinomial. So if we factor out 1/2, we're going to get 6x squared minus 29x plus 28. And I'm just going to expand that a bit just so I have more room to work. Now, 6, 29, and 28, it doesn't have a common factor. So doing my decomposition, I'm going to go 6 times 28 for my multiplication, which is 168, and they have to add up to negative 21. So the two numbers in question are negative 8 and negative 29. And I just searched and found them, okay? You have to do a little work for that. So keep my 1/2 here. So I've got 6x squared minus 21. Oh, sorry, this is not correct. This has got to be for, this is for me, minus 29. Sorry, I need negative 21 and negative 8. You're probably saying, what, Mrs. Finley? Sorry, I was reading my notes wrong. So two numbers that multiply to give me 168, and I get that from multiplying the first and last term, and they have to add up to middle term, which is minus 29. I factored 168 a few different ways, and I found minus 21 times minus 20, or minus 8. So 6x squared minus 21x plus negative 8x plus 28. Whew, sorry about that. And again, I like to put a plus and minus, like plus minus 8x, just so I don't forget about that, okay? So 6x squared minus 21x. I can factor out a 3x, and I get 2x minus 7. And minus 8x plus 28, I can factor out a negative 4, and I get 2x minus 7. And so for my final answer, I'll get 3x minus 4 times 2x minus 7. Okay. Now, next question says, how can you check that you factored a trinomial properly? You can expand by multiplying. If you multiply, if you do your FOIL and then you distribute the common factor, you should be able to get back to the original question. Okay, so that's how you can check. I like this kind of math where you can actually do the work to verify everything you've done to make sure that you're on the right track. Okay. All right, factoring using a substitution. So looking at this first one, we have x plus 3 squared minus 6 times x plus 3 minus 16. Now our first instinct is to, expand this. I should FOIL and I should distribute and then try. However, if we note we have x plus 3 and x plus 3, we can try replacing these nested expressions with variables to see if it makes it easier to factor. And then we would resubstitute that equation back in to solve. So for example, in this equation, we're going to set x plus 3 equals a. So, and I've used a capital A just to make sure I don't forget. So everywhere I see an x plus 3, I'm going to write out a capital A. Now when I do that, then I get a squared minus 6a minus 16. Now all I have to do is think of two numbers that multiply to give me negative 16 and add up to negative 6. Well, that's a minus 8 times a plus 2. Now, I'm not done. I have to resubstitute in for a, my x plus 1. So x plus 3. So anywhere I have that capital A, I substitute in an x plus 3. Oops. Sorry. Now when I do that, then I can simplify, and I get x minus 5 times x plus 5. So that makes that a lot easier to deal with, and that's a difference of squares, right? It's so much easier when we do that. Okay, so let's look at this next one. So what I'm going to do is where I have a 3x minus 4, I'm going to make that equal to a. So this becomes 6a squared minus 21a plus 15. Now looking at this, I'm going to common factor. I can take a 3 out of everything. So 2a squared minus 7a plus 5. Now I still have a factor in front of my a squared. So I'm going to do decomposition. So 2 times 5. So two numbers that multiply to give me 10 and add up to -7. And that would give me -2 and -5. So 3 times 2a squared minus 2a plus -5a plus 5. And then I'm going to group and factor. Excuse me. All right, here I can take out a 2a. So I'll have a minus 1. And here I can take out a -5. So I'll get a minus 1. So 3 times 2a minus 5 times a minus 1. Now, I'm not done. I have to resubstitute back in, okay? And this is the big mistake a lot of people make, is they get there and they forget to resubstitute back in. So anywhere I saw a, I have to go and take that. So 2 times 3x minus 4 minus 5. And 3x minus 4 minus 1. So here we're going to get 6x minus 8 minus 5. 3x minus 5. And I took up a lot of room. So 3 times 6x minus 8 and minus 5 are minus 13, and 3x minus 5. And that would be my final answer. Okay, so you really have to do that resubstitution. Make sure that you distribute when you have a factor in front of your variable that you substituted in. Brackets are your friends. That's all I can say about this. Brackets are your friends. Okay. Now this next page, this is a your turn. So this is where you pause and you try them yourself. And then when you come back, I'm going to just put the answers so you can check your work and see if you got them correct. Okay. So when you come back, just press play again and you'll see your answers. So here, this would be x minus 3 times x plus 8 from our final answer. This next one, you're going to use substitution. Make a equal x minus 6. And then you're going to do your factoring. Your final answer should be 2 times x minus 9 times x plus 2. Okay. Next one, C. Again, you're going to use your substitution and make a equal 2x plus 5 and do your factoring and then resubstitute in. And for your final answer, you should get 2x plus 9 times 6x plus 13. So check that. And hopefully we got all those right. Okay, but it's important for you to try the work yourself to see if you can get to those answers. All right, example number 5, difference of squares. I don't know, for some reason I've always loved them. They are my favorite. So we're going to use that pattern. Okay, so it's a squared minus b squared is equal to a minus b times a plus b. That is the pattern. So here, x squared minus y squared is x minus y, x plus y. Now, this is the same as x plus y times x minus y. Doesn't matter the order, okay? It's just like if you had a times b is equal to b times a, okay? So the order does not matter. So recognizing that perfect square will help you do these answers. So here, I don't have perfect squares. However, I do one-side common factor first. So common factor first, CFF. So I can take a 3 out and I'll get 4x squared minus y squared z to the 4, which is equal to, well, the square root of 4x squared is 2x minus square root of y squared is y, square root of z to the 4 is z to the 2. So those are my square roots. And I just have to have one where they're subtracted and one where they're added. Okay? Difference of squares. I think I like it because it's like a trick. I like little tricks to solve puzzles. So here, these are perfect squares. We're going to do a little more work with them though. So here we're going to have 2x minus 1 minus y plus 4. That's our first bracket. And then our second bracket is 2x minus 1 plus y plus 4. Now we need to expand. So in order to expand, I've got to distribute that negative sign. This has a plus sign so that I can really just open those brackets up. So here I'm going to have 2x minus 1 minus y minus 4. And here I'll have 2x, and again I can just open these brackets, plus y plus 3. I'm not quite done. I'm going to simplify that first bracket. 2x minus y. I have a negative 1 and a negative 4, so it'll be a negative 5. So 2x plus y plus 3. So, and I tend to put them in order. The terms with variables are going to go first, and then your numerical constant will go last in the brackets. Okay? Alrighty, but we're just basically using that pattern to help to solve. Okay, now this is a your turn. So again, we're going to combine some different factoring. So when you're ready, pause it, do the work, and then when you're ready, come back. So the first one's pretty simple. A minus b, a plus b. It's really simple. Second one, now you can either use a pattern, you can also use substitution to do this. But you would go 3x plus 4 minus 2y minus 1, and then 3x plus 4 plus 2y minus 1. If you want to use substitution by assigning this an a and a b, and then substituting them back in later, you can as well. I've just basically skipped that step. Don't forget to distribute that negative sign. This one has got a plus sign. The second one has a plus sign, so you can just open those brackets. So we're going to have 3x minus 2y plus 4 minus 1. Here we're going to have 3x plus 2y. 4 minus 1 is plus 3. So then I'm going to get 3x minus 2y plus 3 times 3x plus 2y plus 3. Oh, wait. I made a mistake, didn't I? This will be a plus. Dun, 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 dun. You're going, miss, I got a different answer. You would, because this should be a 5, because I forgot about distributing that negative sign. Okay? Even the best teachers make mistakes. Okay. For this one, I did choose to do substitution. I made this an A and this a B. So A equals 2x minus 3 and B equals y minus 4. And the reason I did this because there's a lot of stuff going on here. So we get 27a squared minus 75b squared. Now, what I want to do is I want to common factor first. So I'm going to common factor first, and I'm going to take out a 3. Because right now it doesn't look like a difference of squares. But when I do that, I get 9a squared. 9's a perfect square. And I get 25b squared. 25's a perfect square. So this would be 3 times 3a minus 5a, or 5b, and 3a plus 5b. Okay? Now, at this point, I'm going to substitute back in my terms. So I would get 3 times 2x minus 3 minus 5 times y minus 4. And then 3 times 2x oops, minus 3 plus 5 times y minus 4. Okay, big old mess, but we can do it. We take our time and just go step by step by step. So 3, here we expand. We're going to expand by distributing, right? Same thing here. Distribute and distribute, okay? So once we do that, we get 6x minus 9 minus 5y plus 20. Don't forget those negative signs. And for our second bracket, we get 6x minus 9 plus 5y minus 20. Now we're going to combine like terms. So we get 6x minus 5y, negative 9 and positive 20 is positive 11. Then we get 6x plus 5y, negative 9 and negative 20 is negative 29. Okay, so don't be scared of these. Just break it down into the steps. Use substitution if it's going to make it simpler for you. And common factor first. You can probably simplify a lot of your life if you common factor first. Okay? Alrighty. Once you're done that, your assignment from your workbook and